All right, this is Faces in the Fog, identifying users through unconventional means. You may notice that I am missing Justin. He was the one that proposed this talk and this idea to me, and then promptly went on vacation as soon as we scheduled this for B-Sides. So welcome, you get me today. You get me to talk about one of the most exciting topics in application security, at least in my view, right? Like there are some alternative views that are out there. But our story here actually starts with this little string that I've put up on the screen here. A single quote or 1 = 1 with a hashtag after it. You may recognize this, and it has nothing to do with user enumeration. I'll get there. This is my introduction into SQL injection, obviously. I used to work for a little company called iOmega. They made hardware, and there was a click of death thing that happened. I wasn't associated with that, but I was a developer on the website, and this little string cost me a week of my life because somebody put it into the username field on the login screen, and the system decided to load all of the user objects into memory based upon this being sent to the database, which meant that the system crashed because it didn't have the memory. We had Java out of memory, errors all over the place, and we couldn't figure out what was going on. But this was one of my introductions into security in the modern era. And after having this experience, moving into a penetration testing role, we started to test applications. And I lived for 5 to 7 years on this string. This paid my bills. This was in every single, or pretty much every single report that I wrote for years and years. 90 to 95% of the applications that we tested had SQL injection problems somewhere in the application. And yes, it's gotten better over time. But my argument today, and where this research is coming from, is that enumeration flaws that we see in applications as testers are as common in the applications that we test nowadays as SQL injection was 15 to 20 years ago. We did analysis. Part of the reason that we wanted to talk about it was the number of vulnerabilities that we find enumeration specific when we're testing applications is through the roof, right? Every single application that we test, pretty much, with a few outliers, actually have problems with it. So what does this go back to? This goes back to the basics or the crocs and socks of application security. We talk about authentication, we talk about authorization, we talk about auditing, and as a gray beard in the industry, it seems that my job is to just talk about the dad topics and the crocs and socks of application security, which I'm okay with because these are the features that may not be super interesting, but are exposing our applications, our organizations, our users to risk that we probably don't do it. All right, so that brings us to this idea of enumeration. We're going to do a short run through of what it is, where we actually see it, some of the new techniques that are out there for identifying it, some of the research that we've been digging into with new tools, new availability. But realistically, it's uncovering authentication tokens that are used by the application to identify users. The most common, username or email address are the two that pop up over and over and over again. Sometimes we get other tokens that are associated with it and give access to certain portions of the applications. We'll talk a little bit about that. But realistically, it comes down to identification, authentication tokens, authentication flaws that are in the majority of applications. So, basics of enumeration. Like I said, we're identifying users. There's some number, there's some identity that's associated with these people or with these accounts that are in an application that we're testing, or that we actually want to find out more information about. So enumeration occurs when an application reveals existence of that unique piece of sensitive stored, and whether or not that's a username, a password, a name, an email, social security number, right? That was one of the initial vulnerabilities that I actually dealt with social security numbers. but it's not explicitly a security issue. So you think about something like Amazon. Right? What do they care if they have enumeration on products, right? Or even like a number of different items that are in the database. Yes, usernames might be sensitive, user IDs might be sensitive, GUID values, but not all of this needs to be protected in the same way. That is part of the problem that we're running into, is that we don't have the same protections built into place for those sensitive tokens that we may need as we're moving forward. But anytime those tokens are used for that security decisioning, those controls that enforce some sort of authorization or authentication of the application, that's what we're going to be doing. Exposure allows for exploitation here, whether that is through something like credential stuffing attacks are fairly common nowadays, or just straight up brute forcing. That's a common method, and we're going to talk about that. So enumeration types. There's 3 or 4 different enumeration types that we run into. First of all, explicit. And this is probably the one you're most, it's one of them that you're probably most familiar with, right? A call that reflects positive user existence, and usually these are on registration forms or other places like that, but you can browse directly to a resource, get back a positive, negative response on whether it actually exists. So an API call, like a RESTful call like this with an email address, hey, it's going to tell me this exists or it doesn't, and it's so that I can register for the application or do something else. Public profile pages. These are, for especially social media applications, what do we care, right? Like, this is the whole purpose of a social media application. This becomes a bigger problem if it's a loan application or something else like that. That data shouldn't necessarily be exposed. Testable values here, what you would expect: email, user name, account numbers, account IDs. Sometimes they're iterable. Right? That gets us more into authorization and insecure direct object reference or BOLA access. But there are times that is used for authentication and is enumerable ID. Content-based. So these ones are explicit. That means like a direct call, not a lot that goes into it. We get a response back very quickly. The content-based are more what you are traditionally exposed to. You think about the login screen, and it's going to give you some sort of user not found or login failed, right? Like different messages on the screens specifically that built into the content of what you are viewing. So examples, so I've got that for the login screen. Forgot password is another place that we see this often. And sometimes it's the flow of what's going on, but normally it's just some sort of content response that's in the application. And then we have error-based. These get to be more nuanced, and this is where we're seeing more and more of these actually pop up. It's not, we all know about the login screen, that we shouldn't actually be giving messages that are explicit, right, as far as whether that user exists. But we often forget about the error responses that turn around and give us that same sort of information that we can glean about a specific component or object that we're looking up. So if it says 404 not found versus 403 unauthorized, that's enough for us to know that that object actually exists in the API or in the application, and we can use that for authentication tokens. We can start to actually gather that data back up. So I've got examples up there. Again, the same kind of like IDs that we're looking. Timing attacks get very interesting as well, right? So this is the timing type that we're talking about. The way that we actually construct applications can give indications based on how long it takes to respond on whether or not the object actually exists. Think about a login flow. If the user exists and we're doing a decrypt of the password, we're creating a hash there, and that takes 300 or 300 plus milliseconds to actually perform and generate that hash. If we don't do that same condition when the user does not exist, there's enough time difference between those two items that someone could actually start to identify what is there and what exists. And again, like this is stuff that we've seen. Same thing with like edit profile screens and other places, 403 responses. If they do the lookup first as they're pulling data back, and the database lookup takes longer than it is expected when a user exists versus doesn't exist, that's a positive reinforcement that we can actually enumerate and put things together. So testable valuables, anything that triggers those expensive operations. All right, so locations, places we see it. This is where we're going to get into a lot of the examples. First one that I have up here is an example of a login screen. And all of these, right, like funny enough, like we test applications, we look at source code quite often. Most of these examples that I'm putting up on the screen are actually all from the same application. And it was not one that was purpose-built for this one. Sign in with credentials, we've got not email. The problem here is the email required versus invalid passphrase. When the email actually exists and it's in the database, in this lookup, there's a little bit of code snippet that we're missing there. It returns an email, a required message. If it, the messages are different, basically, if the object exists in the database and it does not. That's very simple. You'll see these sorts of messages on login screen quite often. Couldn't find that email. If you're a member, you'll need to create a new account. And that's incorrect password, right? Like that sort of content-based enumeration is fairly easy to detect. We see it in scanners should be able to pick this up, but funny enough, we won't actually see a lot of scanners that identify enumeration in this manner because it does require some context and some forethought into what's actually going on. Capture triggers can subtly indicate a real account as well. Again, some of the timing and other things that run into that. Hey, if the account exists, then we actually require the capture, or we don't. Or the flow itself, hey, if the account exists, then we ask for an MFA token, or then we ask for some additional piece of information. My initial experience with this was actually at Zions, as I was helping build their pen test team. The web developers decided they wanted to onboard everyone in all of the customers, all the accounts that were live, into the new web application that they had just built for web and online banking. So they decided to build a form and ask people the one piece of information that they knew about them in order to register. That single piece of information that they asked for the customers was the social security number. And all they were doing was confirming all the social security numbers that were valid for accounts. And then on the next page, they would ask account details. So all we did was went to the social security website, said, hey, give me all of the Utah-based social security numbers, like prefixes that were issued from 1960 to 1980, and ran that through a brute force tool, and were able to identify, out of 1 million requests that we made, something like 300,000 of those social security numbers were valid for customers of the bank. And again, this is just the account login, the account registration process that we're looking at here. And that goes to this sign-up flow, right? Unauthorized access, like this has some other role issues that are associated with it. But you'll see the validation of the email, right? Like, okay, it's required, number one, passphrase is required, but then it does this decrypt hash down here. And if the existing user is there, then it gives a user already exists message. Simple enough. Create password, this is, and again, we call these all different things. And this is part of the problem that we see with the enumeration in general, and the reason that we find it is developers forget that we're identifying users in other places besides just the login form. So create passwords, user sign up, forgot passwords, what have you. All of these different locations end up showing existence when they don't intend to, especially to users that aren't necessarily authorized to know what that list looks like. So in this case, right, like we've got, test legacy Rachel is the username that we're testing here, but we get an error back from the API that the username is invalid because it's not available. There's a little bit of context that we're, and again, I think this is why we haven't written tools around user enumeration up to this point, is it is very context application specific, endpoint specific, whether or not we actually want to run these tests. All right, existing user, I mean, this one's pretty, easy, right? Like it's already in use or status is pending. Now, in this case, this was found on an account update screen. So I already had to have an account in order to actually execute this code. So on the account update screen, I would drop in a new email address and say, hey, I want to use this. but when it already existed, it would tell me that was a problem. And, again, like from a threat perspective, whether or not this is something that we're concerned about, it's one thing if this is a social media application, it's LinkedIn, you already have their email addresses, they're sharing it. It's another when it is a dashboard that banks use for loan applications, and you as like the application developer does not want the customers to know who the other tenants that are using, who the other competitors are that are using that same platform. That's the sort of risk that we're going to start talking through and thinking about these screens. All right, forgot password, send auth email. Again, right, like, it all kind of comes back to the error messages that we're sending back. And we're going to dig in a little bit here shortly to the responses and what they should be, right? Whether or not the email can be updated, whether or not we can process those chains, what have you. Like when we built out this list of just like number of items that we'd found across the enumeration landscape, it was rather eye-opening to us as well. Just how many places it can exist in an application that we forget. Valid accounts, delays, timing, everything else. And then it's the second that we start to deal with other sensitive tokens, right? EIN in this case, right? Large applications that service multiple organizations probably you don't want your social security number, you don't want your business EIN exposed to attackers in this manner, because it means, hey, I know that this is a place that I can find data about, Seth's company, because I looked up their IEN or their EIN here, and it told me that it's in use and it's already been registered with this service. So account lookups, error-based enumeration is pretty common API-wise. We don't always get the error messages back across like this. A lot of time it's suppressed nowadays. And I think this is part of the reason that we're seeing this. From a location perspective, we know that the error messages shouldn't show up in our React application, our front-end application, but the APIs are very explicit about what they return because we built requirements for them to be explicit to the developers. And just inserting yourself into that flow, you can actually see a lot of this as it comes back. All right, account lookup, account lockout. This is one that people often forget. So in the case of this code that we're looking at here, right, we've got user exists and user password reset requested at, and then it returns like this password reset email has already been sent. Now, this means if I'm actually looking for a positive negative response, I have to make 2 requests, not a single request to actually build out my list and perform the enumeration attack, because I've got to send it once and then send it again to see if I actually get that message coming back to me. If I don't see it coming back, then I know it doesn't exist. It's going to take a little bit longer as an attack. I just doubled the amount of requests that I have to make, but it still is, that's more than automatable. Login, so account lockout, this becomes a little bit more expensive as an attacker, so that one's double. Most account lockout schemes will happen within 5 to 10 attempts to log into an application. The user will get locked out, or you'll start to get messages saying like, oh, the lockout, you only have 3 more attempts, something like that. The second that we start to give those messages back, it is confirmation that the account exists. An account that doesn't exist, if I try it 10 times, I don't get locked out. All right, that's great. I'm going to move on to my next target. Go. All right, so from an identification perspective, how do we actually identify enumeration? This is the traditional approach, right? I'm going to identify the possible endpoints. I'm going to manipulate the known valid values, see what responses come back. And then I'm going to check the response for those enumeration indicators, whether it's timing attacks, whether it is anything across the board that we've talked about up to this point. I think part of the reason that like this gets, again, to be difficult is that there's not a standard, like a one-off approach to actually do this. It is very context specific. And if you look at Burp Suite, that's what I've got up on the screen here, there is no specific tool or specific target that actually Burp Suite uses to perform enumeration, or to positively identify enumeration. There's tools that we can use for brute forcing that are built into it, but there's not even a plugin, a Burp plugin to do that analysis for us. Now, there's some of the new like Burp AI stuff that's come in that may actually be helpful from this context. There's the authorization, the auth analyzer, and a couple other plugins that will give us some of these indicators. They've built in a number of presets like usernames and email address generation that we can use. But again, we're turning to Intruder at that point, and we're just using it as a brute force tool. There's no reason, there's no real knowledge about the application to identify those users or those email addresses. So we turn to static. Like, let's turn to the code, let's take a look there, but it's very much the same process. We identify the endpoints in the application, we think a little bit about what the response is going to be, we're going to look at the error messages that are coming back out, and then we have to analyze all of these flows, look for timing attacks, look for password hashes, look for secure comparisons, look for database lookups to actually figure out whether or not we're going to be vulnerable to this. What we found over time is that the best approach is to look statically and then test dynamically. That's very common in a penetration test, especially the open box ones that we do. But it is still a time-consuming activity to step through each of these and actually to make these calls. And we want to speed that process up. So, if we're looking statically, we're going to look at, this is out of a Django application. We're going to look at all the URLs that are being called, that are being accessed. Some of these may have some sort of enumeration in it. From a general swath, without experience, you're probably going to call out the login page. You might call out register and, what else would we call it there? Maybe the change password, forgot password, reset password flow. Those, are fairly common. We know that those are going to be an issue. But there might be other places that we're forgetting about just because we don't know what this application does, how it's handling those tokens, and what else could actually go into it. So if we look, we start to do that trace further on, we're going to jump into, I think this is the login flow right here, but you do see account lockout there. Oh, you failed this number of login attempts. Okay, there's enumeration right there. And then below that as well, you've got differences, failed login versus invalid username that's being sent to the rendered page itself. I'm still going to have to trace further and further and further. It's going to become a little bit more of an intense project to actually get through it. This example comes out of a different one. Oh, this is the one that I think I copied it in. Oh, no, yeah. So about halfway through this one, there is the compare sync that's there, where we're actually generating the token, the hash token or the hash value for the password from bcrypt, but we only do that when the person exists. So it's a timing attack, right? And this application itself was actually safe from all the other enumerations that we found, but the fact that it wasn't actually doing this timing comparison when when we create the password, if the person doesn't exist, it was enough of a distinction even over the internet that we were able to identify enumeration. Okay, so I want to talk about modern ways to actually do this and identify locations where enumeration can actually exist. It's all the hotness, right? Like the talk before me, they were talking about pen testing, like red teaming with LLMs. We're going to do the same thing, but we're going to use it to build context about enumeration and speed up our identification of of enumerable endpoints and maybe values that we should be concerned about. So instead of trying to do this manually inside my brain, looking at the code and doing everything, first thing I'm going to do is actually browse the application. I'm just going to browse it with Burp Suite. I've got that preloaded up here, and I'll show it here in a second. But we browse like a vulnerable application. I know that has multiple locations where enumeration exists. Exercise all the possible functionality where authentication could happen, where it could possibly be a problem. and then I'm going to export that session, and I'm going to send it to an LLM with a prompt that's using reflection, using modern prompt techniques, and ask it what it thinks. Now, I've done this with multiple different LLMs, everything from DeepSeek, like the reasoning LLMs, the newest versions of ChatGPT, to Gemini, and others. I found that the Haiku models from Anthropic are actually the best at the identification and even spitting out details as I want them. So that's what we're going to use in this case. And so let me just run through this. So the first thing that I did here was I actually ran through, so this little application, anybody that's been to my talks or has seen this before, like probably recognizes the vulnerable task manager that we use for all of this. But log in, we can do whatever, right? Like this is just a purpose-built like vulnerable application that has a whole bunch of vulnerabilities that are to it. The next thing that I did is I actually jumped over to here, Burp Suite. I took this vulnerable application. I dumped out all of the session itself, which is just XML HTTP requests and responses that I'm interested in. I want to know, hey, is there enumeration that actually exists? And then I swing over to actually writing a prompt, right? I've got a system prompt that's laid out that's using reflection. If you want to talk about AI and LLMs and how to actually use them to identify vulnerabilities, whether it's in code or whether it's in running instances, like we can do that at a later date. I'm going to post this up on my GitHub here shortly. So Seth Law is my GitHub handle if you want to play with this on your own. But what we're doing is we're using reflection, we're doing analysis, and then I'm asking it basically, hey, I'm giving you an HTTP request. I want you to analyze it for the possibility of user or email enumeration. Let me know what you actually find. And I'm only looking at the request. I'm not even looking at the response in this using this tool, right? Yeah. And then, realistically, I'm just pulling apart that XML. That's all that this is doing. But the meat of it here is, hey, can I use an LLM to actually speed up this process so I don't have to spend as much time thinking about enumeration as I did in the past? So I'm going to pick this off here. Take a look. Do I need to pray or sacrifice a goat to the demo gods really quick first? But here we go. User enumeration. So it's parsing through all of these requests. And you're going to come back with this, like possible user enumeration. Okay, I've got no there. Project details. Yep, no direct evidence. I tag this with justification because I want to know what's actually happening. Right? No enumeration. I went to the upload page, apparently. Nothing that's direct in any of this so far. And again, I'm just looking at the request. I could expand this out with the response as well. And most of this, looks like it is, fairly valid up to this point. Now I get to this, okay, download profile pic. Now, this is where it gets interesting because when I designed this application and I was thinking about enumeration, I didn't even call that URL out as one that was possible. But it is saying, yes, look, it's possible user enumeration because in the URL, I've got a user identifier that exists, and I can enumerate through, and I can use that to populate my list of possible user IDs. Okay, forgot password. Yes, it definitely is saying, like, hey, look, there's whatever, right? Like it looks like there is the possibility here to do user enumeration. And all I'm doing here is I am refining the list of endpoints that I as a tester am going to go jump in and actually start to look at. So yeah, so we're stepping through here. There's 40 requests or so. Again, I'm using the Anthropic model. I'm using AWS Bedrock in this case, right, to actually do this analysis. There's some interesting post parameters in here where I'm doing injection and other things. But those download profile pic, forgot password, okay, manage groups, right? Like doesn't look like there's anything in there. But it does say that there is a refer header has something with Chris in it there. So it's pulling things out of the components that could be interesting to me over time when I am thinking specifically about enumeration. Now, again, I get to the profile URL, profile 3. Yes, user enumeration is possible there because of that public profile like we talked about in the past. Reset password, searches may or may not necessarily be there. Anyway, okay, so that is, the demo gods worked that time, so thank you for sacrificing the chicken, whatever it was. That gets through the list of 42 items that I had in here. And honestly, the script took me probably 15, 20 minutes to write to actually, refine this analysis from an enumeration perspective. That was, time well spent. And again, initially, I went through and, okay, that was the only thing I was looking for. But if we jump back over to the presentation, that brings me to actually attacking the exploitation or attacking the enumeration and being able to pull data back out. Traditionally what this has meant is just been straight brute forcing. Like I showed before, all we have in Burp Suite is intruder that we can use for this, but we do have to have a very specific payload set. It's automatable, but it is also easy to detect. The cons here are bot preventions that we start to run in to large key spaces, right? Yes, Burp gives me a list of 200, 400 usernames that I can use, but how valid is that for custom applications? Yeah, it's not very valid. I'm going to have to go and do some research and figure out what's actually going on there. But it's effective over time. This is an example of enumeration of various tenants or various customers of this application that we were looking at that actually led to different websites that were implemented on top of this platform. And because they were only using 3-character token values to define where those dashboards existed, it was very easy to enumerate who are the other customers of this organization. And again, these are competing customers. They probably don't want to know about each other. And it's all because they're just using these very enumerable values that are there. And again, you'll see that response, the length response that we're coming back from. This one's pretty easy to determine. It's actually same thing here, building a list of usernames, right? We're taking this list that we had to actually prepend this and do a little bit of OSN to figure out who worked for this organization, build a list of possible username, and then we have invalid accounts that exist as well. And it all came back to the response timings, right? How long it actually took for it to respond. When it did exist, so this is the flip side, the timing attacks I talked about before, we thought, it's going to take longer for a valid account to come back. But in this case, it actually took, 5 times, 10 times as long for an invalid response to come back when it aired out, as opposed to a valid account would come back almost instantly. The problems that we have with exploitation, like I was saying, building a list of possible objects, if it's GUID values or something out, we got to figure out a way to actually retrieve those. The key space for email addresses is huge. Anybody ever written a regex for email here? Really easy to capture all of the space that's possible. Bot protections actually prevent a lot of this from happening, and GUIDs make enumeration, so it's nearly impossible. Again, GUIDs are, random. So from a solution perspective, we, instead of depending on what's already out there, we want to extract valid identifiers from the application in some way when we're doing the testing, so we can get this response in and we can build these tools quicker. OSN here is your friend. We can use LLMs to build a list of those custom domains, usernames, whatever it is that's actually there. Thankfully, right, both Google and Microsoft are very, very helpful when you want to enumerate email addresses. An organization exists, the format that they use. Anybody actually have their own email server that they host anymore? Does anyone want to admit that? Okay, yeah, so everybody's using either Outlook, or Office.com or Google Workspace. I guess there's some outliers that use iCloud or whatever Apple has, right? But as long as you can identify that this is where the email is going, it's pretty easy to actually go and say, hey, do these actually exist? I don't have to attack your application to get this list. I can go to Google or Microsoft for this. Now, there's some bot things that are out there that we're going to, deal with. But it's pretty easy to build a list of valid email addresses using services. So the solution here is you've got to think about payloads, right? It's very easy, and the easy button is just to turn to what Burp Suite or whatever already exists in sec lists or those different buzz databases that are out there, but they're usually not specific enough to be really effective in exploiting and attacking enumeration endpoints. We want to put some thought into that actually before we turn to intruder before we use an LLM to actually go and identify those valid users, and then we can get to credential stuffing and some of the further attacks that are there. One of the things that I love about enumeration is this is typically the gateway to full exploitation of an application, and it's required to know, like, to take over an account, and the first thing we have to do to take over an account is actually identify who it is. So we can do that to actually win. So I took that same script and we modified it to extract users from that same application, from that same session, to actually see what sort of user details are already included in that. So in order to do this, instead of just sending the request, now I'm sending the request and the response, and I'm telling it, hey, give me the users that you identified in this. And you'll see, some of them come back with nothing. I logged in with this Chris account, so you're going to see that come back over and over. But there may be like other places that I can start to glean this data. And we don't often think about this when we're giving data back to users. I mean, like, this is all sensitive data because it is being used to log into the application. Now demo gods are going to curse me because I am using LLMs on the back end. Or maybe I've overloaded Bedrock, I guess. Project details. I did want to, take a second and look at, the different ones that are coming back. But you'll notice, okay, on the upload page, not only was Chris, oh, geez, sorry. All right, so this is what I'm running here. I didn't realize that. Yeah. So I'm doing analysis on, I'm using an extract users, very similar, but now I'm asking the LLM to give me back a list of the users that it's identifying. And you'll notice it's even pulling things out of like tokens that exist, like cookie values that I didn't see before, but there is a user ID that's associated with that one. The upload screen, for some reason there's Chris, but there's also this admin account that got flagged in some of the response. So somewhere in that HTML, it's being scraped out of there. Now, this doesn't mean that I couldn't write an email regex or a username regex and to do the same thing. The nice thing about the LLM is I can just talk to it directly and say, I don't have to give it like an exact specific pattern. I can just be like, hey, I want to know about users. I want to know about any users that you find in any of these pages. There we go. There's Seth, because that's that profile pic that came back, right? The name of, and these get interesting because there is a Seth account. The name of the JPEG itself that's being returned from this is Seth.jpg. That's where it's pulling this information from. I'm going to start to push this into other specific places. Now, some of these may or may not be misnomers. Info.tm, chris@tm.com, that's valid, but because it is using, it is looking at the full request and response, I know that email address doesn't exist, but it's still going to pull it out because it's seeing it as potentially a valid list. Let's see if we get anything out of this. All right, and then we get to places like manage groups. Hey, it found a drop-down list there of all of these usernames that had been registered with this application, right? Fairly interesting that there is different values that are associated with it that are in the database that I didn't even think about, right? That manage groups wouldn't be a place that I would necessarily tend to get this information back out to actually pull the data. Manage projects is the same way. So it's finding all of this. And again, this is a process that probably would have taken me an hour or so to comb through all of this data, to look for these, to do IDE searches, to look for things within Burp Suite itself, to identify these values. But like the LLM's giving me that access very, very quickly. So where does that take us? Like, if I am a developer, I'm creating an application, I'm trying to prevent this from happening, this is going to be it's not an easy process, right? What is the most common way that you think we would mitigate or eliminate enumeration? We're going to make this more interactive now. I'm tired of talking. Any ideas? Remove all the error messages. Yep. That's, I mean, definitely that's the number one thing that we should actually see, right? Enumeration is hard. You can be like, Google and Microsoft and just not do it, right? Shift the risk to your customers. Because we can enumerate all those email addresses. That's great. They do give very specific options to help with that. However, one of the things that you can add to your arsenal there is CAPTCHAs, obviously, MFA, any of the 2FA tokens. Like the second that we start to introduce some of that, it reduces the overall risk of enumeration, especially during that authentication flow, because we are going out of band. We're using a separate device. We're using SMS. We're using some sort of email that we're sending to clients to actually validate that person, as opposed to just the email and password, which ends up being in the breach databases that are everywhere. It does really come back to the code itself, right? Like how we handle the error messages, how we actually remove them, how we, we're using generic error messages across the board. Like there's no reason for us to be that specific. Most users of an application, I don't know about you, but when I put in the wrong password 2 or 3 times, what's the first thing you're going to do is hit forgot password, right? Like we're not going to mess around with that anymore. But I know we're at a tech conference, so like that's probably not the general sentiment. A lot of people will just like try their iteration of, okay, I did spring 2002, now I do 2003, 2004, 2005, until I hit the right spring when I last reset. Secure timing comparisons. This is where it gets really difficult, because we just have to account for, okay, yeah, we're hashing a password, we're doing a lookup, but we also have to account for, hey, when that, the positive, negative responses that are in there, we're hashing things when we don't necessarily care about it, but we're starting to do secure timing comparisons of the different values as they're coming out. There's not really a good way to catch that outside of testing it and looking at the code and thinking. And that goes back to this, right? Like the compare sync that's here. And whether or not that actually exists, we actually, we should just be doing a bcrypt no matter what if we want to get around this one. Or a sleep, which is crazy, but putting a sleep for 200 or 300 milliseconds throws that out of the window, and it means that an attacker could not necessarily enumerate that. And I know that we know that it's difficult, right? But this is still a focus area. I would like this to get better. We're going to be, like I said, I'll be posting the actual code that we're using for that LLM analysis. If you are testing an application, you're interested in enumeration, feel free to use it. Feel free to jump into Wasatch AppSec or other places, and start the conversation, because it is a hard problem. I'd like to see it, like the number of them actually reduce in my reports. I'm getting tired of talking about it, so instead I come and talk to more people about it, right? But if you do have any other questions, I'm at Seth Law on social media. I'm one of the co-hosts of the Absolute AppSec podcast. Justin is at Phantom Traveler on social media, and he'll be here next time, I promise, or I'll send him instead and he can talk about it, because he gets all up in arms about this as well. And you can find us at Redpoint Security. We're also here, we're sponsoring as well. I'd love to continue that conversation. And yeah, but otherwise, that's everything that I've got for today. Are there any questions before we go ahead? Yeah. No. This is partially because the questions that I'm asking aren't, hey, tell me how to exploit this. It's like the simple, if you look at like the prompts that I'm pulling into it, pull those back. I've never had problems, especially with Haiku, and maybe it's because there aren't guardrails that are up there. The way that Bedrock is, situated, it's basically just, hey, it's an LLM that you can send a system prompt to. And maybe maybe we're getting around it because the system prompt is, you're a highly analytical agent specializing in both security and functional review, right? Like I'm not telling it, hey, I want to hack this site. I'm saying like I'm doing this from an analysis perspective. Again, like some of those strategies they use from a red team perspective to get around the prompts or get around the safety guardrails that are built into that. That's probably what I'm referring to. into here, or I'm not running into. Yeah. You'd be surprised. That probably cost me about less than a cent, especially against the haiku model. If you're doing that, like 3.5 haiku, 3.5 sonnet, they're fairly inexpensive. The second that you get to the reasoning models, the price like 10x that price. The new sonnet model, the 3.7 is a lot more expensive. Again, it's got that reasoning capability. The one trick here that we can talk about as well, you see that reflection that I've got up there. Is that turned out to be the key to actually getting back the data that I wanted. Instead of having it going to one of the reasoning models and having it do its own reasoning, just telling the LLM, hey, I want you to reflect on your initial output and rethink what I'm asking, ends up being incredibly effective. So if you're doing model or prompt engineering for AppSec tasks, you should be using reflection. Cool. Yes. One of the problems that I have is, so if you notice the output was very structured, right? One of the problems that I have with the reasoning models is they just ignore my structure requests. And it'll come back with, it'll get to the fact that there's a justification in there, and it'll decide that in that justification, it's going to start telling me about authorization issues or the possibility of SQL injection or other things that I didn't ask about, because it's trying to reason out, hey, I'm a security agent or whatever it is. And this might just be me building this prompt specifically for, certain models as they came up, and the reasoning models need a new approach to that. But I've had it, so we've used them. It's just been more difficult to actually structure. And again, I'll push the code up. You can play with it. You can try it out with the different reasoning models, even the ones that you can download. Like I said, DeepSeek locally, or 5.3, or a couple of those that you can run via Olama. It's fairly easy to do. Yeah, and let me know what your experience is. Come to Wasatch AppSec, the local OWASP group, and we'll continue the conversation. So, all right. If there's no more questions, thank you so much.